Alright, this is going to be about basalt, and basalt is not understood. And these are things right here would be considered basalts. And they're not basalts, they are remnants of fossilized creatures. And I have the evidence, and I have DNA extracted from, this one was a human lung. It was DNA tested as human, 100%. And it has all the patterns of human investments and everything, the tab at the top, the tab at the bottom, the airway thing is here, you know, the airway passage going in there, the circular investment. This is fascia and pleura, which is a fabric coating. The Greeks used to call it tunica, and that was DNA tested as 100% human mitochondrial DNA. These are also creature parts, and I'm going to show you the truth about it. Now, I'm going to show you why everybody thinks basalt is just something that's from volcanoes, but it's not. There is two types of basalt. We know that basalt comes from volcanoes. I mean, who doesn't know that? But how about this? There's another one that's called right here. Where is it? Well, these are basalts and mafic extrusive rock. Here's the deal. They sort of hide this because they don't know how to explain those hexagon basalt pipes, and I do. Now, mineral content, ground mass generally of pyroxene, augite, plagoclase, and olivine, possibly with minor glass. Now, here's the key. Here's the smoking gun, and listen carefully. They call this porphyritic. I don't know where he came up with that, but porphyritic. If porphyritic, there will be fencrysts, and they will be of either olivine, pyroxene, or plagioclase, or a mixture. And that is exactly correct. But porphyritic has nothing to do with lava, not a thing. It's from creatures, and I'm about to show you the absolute positive facts on this. The chemistry, spectral analysis, the whole shooting match is done, and the DNA is done. 3 DNA tests, 7 CAT scans, the chemistry's been recreated, and I'm going to show you how the process recreates a feldspar, and the internal parts turn into these pyroxenes and plagioclases and olivines. Now, I have a group on Facebook. It's called Mudfossils, A New Science, and it literally is, because this is how this started. Was I found some rocks that were obviously creature parts, and I started to study all rocks, and I found out that literally all rocks that are not from volcanoes are creature parts. And the key is that they all have blood investments. You see that red and that black? That is the signature of the red is ferrous oxide bloods that are oxygenated, that are arterial bloods, and they have an extra oxygen. It's FeO3. Now, when it comes back, after it goes through the tissues, it comes back as blue blood in the body. It's black when it comes out as ferrous oxide FeO2. It's a different oxide, but it's still loaded with iron, and that's what happens. Now, the fabric of this is fascia. Every piece of every creature, every fiber, every cell literally is coated with a fabric that isolates it from every other part so that it doesn't stick together. And tendons specifically have sheathing, and they have, and I'm going to show you this in a minute, they have a fascia that coats it, and you can see this in your steak when you cut it open. You can see the muscle groups are separated by that white fabric fascia, and I have actually petrified fascia here that I will show you in a minute, a couple things that go with this. But go to this Mudfossils, A New Science, and it's an open group. Now, I don't allow many posts about just crazy things because this has to be verified. It's not that they're not taking this serious. But I have 3 DNA tests, 7 CAT scans. I have everything I need, and I have tons and tons of specimens. So anyway, I'm going to go through all this stuff, and if anybody's interested, I'm interested in getting somebody to look at this that has some, validity in the world of academics, which I have none. You know, I may not have any validity, but I do know what I'm talking about. This is all, I mean, this goes back years and years and years, but believe me, once you do all the stuff I did, you do not forget this. And it goes on and on and on. And this is all about chemistry and about bonding and how things work. And, you know, I mean, it's not something I did quickly and forgot about. And then I also did all the lab analysis and the tests about how things, you know, the heat and all the stuff, all the electrical changes that happen, and it's all about chemistry. So anyway, that's the deal. But it's literally proven, and I'd like to have somebody peer review it, because I'm not accepted, but I do know what I'm talking about, and I have the specimens, and I have the DNA tests, and everything else that was required and asked for, and now will not be examined. All right, not only do I have CAT scans and DNA tests, I literally made my own mud fossils in my little shop here. Now, this is one of the mud fossils I made, and it's not completely solid like a rock yet, but you can see that the tissue is being invaded and becoming crystallized and turning into literally feldspar. And the feldspar is a result of silicon in skin tissues, which is dense in skin tissues, 50 times more dense than it is in other parts of the body. It's a connective tissue, and it's structural, and it keeps you from scrubbing your skin off. So it's a strong component, and what it does, it's silicon. And in the body, it floats around and does its job. But when it loses the support of the body, it tries to find somebody else to bond with, and it looks for oxygen, and it gets it. And in wet conditions. And you get Si, silicon, O2, oxygen, which is sand, silicon dioxide, and it's feldspars. And you get like irons and, you know, magnesium, aluminum, all of the blood chemicals that are in bodily tissues also are impurities in these little quartzites. Now, they will erode off and become literally sandstone. They're the sedimentary parts, which are sandstone. After this sand, which once it petrifies, this sand erodes off, because you can see it's little granular things. They're going to erode off of here. Underneath is the mudstone. Now, I'm going to show you the next one here. Let me go out to 49 here. All right, now, where am I? All right, here's the difference between what I just showed you, and this is chicken tissue. And let me just explain to you how this works. Mud fossils are a product of things that are petrified in wet conditions, you know, like the bog people and so forth. But when they're deeply impacted in mud and there is no oxygen, and the earth automatically puts out electrical currents. It just happens. They're called telluric currents or spontaneous potentials. There's a couple different names, but they literally create electricity in wet conditions. Now, so what I did was I used different soils and sands and so forth, and I couldn't do this all the time because I don't really have the facilities to do it, but I did it in the winter when the things didn't rot and smell, so they were semi-protected in like refrigeration conditions. And then I electrified it so that I was pushing, 12-volt battery, and I was pushing electricity like you do plating a cheap ring. And that's why it does what it does. It crystallizes whatever is in the electrolytes, which in this case was water, and there was some salts and things, but just basically water. Now, and sand and so forth, and it migrates and pushes and drives and invades the tissues, and you get silicon dioxide with impurities. That's why you see sand. Now, this right here, though, totally different situation. This is tendons. Tendons do this. They turn into strappy fibers, and they get really frosty looking. They're really kind of gorgeous looking, and they create selenites, and they create limestones. And this particular type of limestone is not like marine limestone. Marine limestone is made out of the exact same stuff, except the marine limestone does not have the blood chemistry. This will have some blood chemistry. You see there's dots of blood in through here. There's little tiny investments of blood that you need blood to do everything everywhere. And that's the whole idea behind mud fossils. You go out in your backyard, absolutely, I guarantee you, in 15 minutes you're going to be able to find your own mud fossils. Absolutely no question about it. 100% guaranteed. And they're everywhere. As long as it's a discrete rock and you don't live in on top of Mount Kilauea or something like that where it's all lava. Anyway, this is what it is. They were all here, and I believe they were here from some huge flood that happened some long time ago, and that is what happened. They ended up being impacted in these deep muds that collected, and they became mud fossils. And then I believe at some point in the future they were tilled by glacial tilling and pushed up to the surface and into moraines. And then you get these piles of rock, and that's where I'm finding all this stuff. You find them everywhere. Anyway, this is the tendinous stuff, which is limestone. And limestone is basalt. And basalt is calcified material. And, well, first of all, there's two types. Let me stop this because I made a mistake. I'm sorry. Basalt, there's two types of basalts. And the first type of basalt is the ones everybody knows about, is the lava. So let's forget that. It's a homogeneous, very highly crystallized minerals. All right? Very little organics. Now, you go into the other type, which is this porphyritic. I can't even pronounce it, but porphyritic, something like that. And that is tendons. And those tendons are those basalt columns. I'm going to show you that right now. Well, here, let me just show you something else about this. Yeah, out here, if you look, this is the, you know how you see those bog people, they look like that. And that's, I think I did this one in mud. But you see this little investment here? That's one of these fascia investments that tags something into a body somewhere. Let's see, this is, all right, so this is some more of, this is the stuff I made. And then there's some out here that were, all right, here, this here, and I'll show you this in a second. This right here, as you can see, this is like the same stuff I made, only this is from a mud fossil. And this mud fossil is a fingertip, and I'll show you that closely, but let's look at the microscope shot of it. You see this strappy stuff? That strappy stuff is the fiber that's in your skin. They're made out of keragens and collagen material 1, and they turn into fibery, strappy stuff, and that's literally the fabric of your skin. Now, within this stuff is kaolin clays, and the kaolin clays are the substrate, or however you want to call it. They're the media that the crystals literally float in. It's the fabric of your skin, and that's why your skin's tough. Now, this is bloody area over here. Let me see if I can find anything else. All right, that's it. Let me show you the fingertip. Here's the fingertip. All right, this right here is that actual fingertip. All right, now you see this here at the end? You see that? That is a garnet, I believe. And all of these little things here, all the little red stuff, is garniferous. They call it garniferous. Now, what it really is, that's a finger, and it's about the same size as my finger, somewhere in that area, dirty fingernails. And what you have is a vein and an artery. A vein sucks the blood back up, artery pumps it out. When you die, the blood gases try to squirt out of weak places, and they squirt out where the blood is weakest, and that's on the end of your fingertip. And trust me, there's very little holding that blood back, and those almost always blow out, and they still do today. From somebody that dies and there's compression in their body, their fingertips can blow out, depending upon the orientation of the body. If the fingers are low or high, and so forth. Anyway, I've got this thing down pretty well, Pat. I've seen so much of this stuff. By the time I was done, I mean, this goes years now. By the time I was done, I filled a 200-foot drainage ditch with what I was done examining, and you know, I just couldn't hold it anymore. I have so much stuff that it's just amazing. And every single part of the body is preserved. I have bursas. I have fingers and toes and lungs and hearts and, you know, every single part. even one complete head. I did this is not my head. I did, well, this mud fossil head is not my head. Now, Jim Burchell and Arlie Caudle, well, Arlie found the head down in Kentucky, and Jim Burchell was doing the autopsy on it. Basically, he had all kinds of things done, and he was right. He had 100% right. And then they showed it on TV, and Scott, I can't remember his name, from Unearthed. He laughed at it on Unearthed. Well, he didn't laugh at it. I'm sorry, I shouldn't say that. He just said, no, this isn't true. In my opinion, it isn't true. But then he wouldn't address it anymore, which I did the autopsy on it myself, and it is, in fact, a head. There's no question about it. And this is the ferrous oxides of the head. I have a video on this. But anyway, nobody will discuss this. Nobody carves the guy's flesh eroding from his nose, and the irises of eyes, and we had a CAT scan done, and there's a sword puncture through the top of his head, and this appears to be a cap, and you can slide a playing card up between here. Every single anatomical feature, including bone form and indentations, vascular orientations of every single muscle, of everything single blood vessel, and that's when I decided that this was now sandstone. Yes, I agree with that. Well, how did that happen? Well, here's how it happened. Because of the petrification process, that silicon is what happens to skin, because it's SiO2. The oxygen invades the silicon, and it turns the silicon SiO2. Now, these are the iron oxides from his blood. It shows on the CAT scan the fractures on his head. There was a big thing impacted his head here. The neck vertebrae in here. I have a video on it. But I mean, all this stuff. But anyway, this was what caused me to say, well, I know the thing was alive. Now, how could it possibly be sand? I mean, feldspar. Now, when you look at it, you'll also see in here it has all of the same fabric of the skin that I'm showing. This is not something that can't be fully understood. It just needs to be looked at, and it's being refused. Alright, this is mud fossil skin. You can see the little white flakes. Those are the calcified flakes. But you see that little black spots, little dark brown spots all over. That is the silicon. Now, I don't know what part of the body this is from, but skin has different textures all around your body. You have skin on your fingertips and so forth, very stiff, and then you have real thin skin on your wrists and so forth. Now, but if you follow this around, here goes the skin. Now we're going into the bodily tissue. And you see, why is this black and why is this brown and so forth? Well, I can tell you why. Because what happens here is the blood comes down in the arteries, and now it's brown here. But at one time it would have been brilliant, brilliant, brilliant red. And as it moves through all these little tiny holes, you see, I don't know if you can see those or not. You may not be able to see them. But there's all these little tiny holes, which are the blood vessels. The vesicles. So it starts to go through here, and as the tissues absorb the oxygen from the blood, the oxygen continues on its pathway, but it becomes a different color, and it turns into blue in the body and black in mud fossils. And you can see all the vascularization. Now, at some point, there was a vein that plumbed into this area and sucked that back up to the cardiopulmonary area to get some more oxygen. But anyway, this is the skin, and this fabric you will see on mud fossils. It's on every single one of them. There. And they say, oh, that's some kind of gabbro, this and that. I mean, they got all kinds of names for things, but this also is a mud fossil. That didn't just show up there by itself. You see that? There's the blood that's from this was what they call ultramafic rock. But you can see, here's the skin. The rest is what they call basalt, but this is where the blood of the bone would have been, because the bone is dense with bone marrow, and there's the blood leaking out. And all of this is the fabric, and it gets squished and flattened because of the tectonic nature of this. This came from, all of this stuff came out of a Rift Valley, which is actually in Connecticut. And here's the selenite. I don't know. I think I showed the tendinous material, but here's a selenite. Some nice lady, Becky Darius, I think her name was. Very nice lady sent this to me, and this came out of Utah, I believe. And it amazingly, she sent me the piece that has the abrupt transition from the calcified mineralized tendon up into the as it starts to go into the muscle tissue. It takes on a different well, you can see there's no more. Well, it may be some more coming in out here, but at this point it looks to me like that's the abrupt transition. Anyway, because tendons have an abrupt transition where they come out in the mineralized form, the limestone, when it goes into the muscle, it cuts off just like you cut it with a knife. That's the abrupt transition. All right, remember my chicken tissue? That's selenite. Same thing, only from a giant creature. All right, these are what you see, these bundles, in the abrupt transition. Now, I believe these are the same as these, are the same as these, are the same as these hexagons. Now, I'm not positive of that, but I'm pretty sure of it. Now, these are the big bundles, and they keep coming down until you get to the fibrils. The fibrils insert into the bones, and I and they call them Sharpie's fibers at some point, which invest right into the bone in these little tiny cavitations, and I have copious amounts of that to show you. One other thing is this: every one of these is coated with fascia. Now, not only this bundle fascially, that's coated with fascia. This one's coated with fascia. That one's coated with fascia. That one's coated with fascia. And every single cell in your entire body, every fiber, every single thing that is separated from everything else by this fascia. And its job is to not fuse with other things. That's why these fibers are independent when you see them as basalt columns. And they contain all of this stuff that you will see in what they're showing as the basalt column fiber, what they call, volcanic basalt columns, porphyritic ones. But they still attribute it to volcanism, which it isn't. It's creaturism. Now, I remember this: DNA tested, human lung, no question about it. And you see the fabric? That's the kind of fascia that creates that you're seeing right there on the screen, which they are calling melt migration in basalt columns. It has nothing to do with melt migration. That is life, and is now petrified, and the reason those basalt columns are separated is because of the fascia. These are things from giants, and here is exactly what happens as the muscle fiber, as the tendon fibers come out this way, they change. There's an abrupt transition, and then you go into the muscle fibers. And the muscle fibers erode because they're primarily made of fleshy material, which is bloody and slurpy and gooey, compared to the tendinous material, which is strappy and hard and calcified. All right, I've been talking about the abrupt transition. Well, there it is. What happens is these here, you see these little board-looking things? They're straps, and they invest into a bloody matrix, which you can see there's some blood investments in here. And then after this gooey stuff, they go into the muscle, and I'll show you that. I think I have this. I should be able to show you how it transitions. You see, here it is. I'm showing a little further, and it's coming out a little further. Well, here, let's just play it. All right, I'm showing the bloody investment of the tendinous material now, and I'll show you an Achilles tendon and how those straps look, and then some microscopic shots in a second. But what they do is they go into, I'm showing the bloody little spots where blood goes in, that services that tissue, because everything needs to be some form of blood to keep it going. Now, I'm going now towards the muscle, and you see how we're going away from that. You see all the little white fibers and things? That's minerals, literally minerals, and that white stuff there, those are calcium minerals that are in your body. The collagen type 1s they make up. Now we're going into the strappy fibers of your actual muscles. And that is the muscles, and I'm going to try to focus that in a little bit and get it close. And you can see that is the actual muscle fibers, and now they're starting to spread out like they normally do. And you see those holes at the bottom? That's blood investment into your muscles to keep your muscles pumped, and then it breaks off at that point. Right after that, they all do. And that's not the abrupt transition, but that is because it goes from the mineralization of the tendinous material into a real fleshy material. It erodes, and it'll erode right here. Well, you can see the little flashes of light, and it's gone. Now, strangely enough, as I kept going through finding out rocks, and literally all of them have these attributes, if you know what to look for. Some of them you're just not going to find it because they're so transitioned into minerals and crystals that they're not going to be recognizable by a lot of people. Now, however, I did go out and to look at meteors and meteorites and comets and everything, and Comet 67P has a lander out there, and it's on there taking these pictures, and lo and behold, that is also a tendon. Now, watch this. You see this up here? You see those little blood investments coming into it? And you see this structure coming down? That is the stalk, and would go out this way as a tendon fibril from an Achilles tendon. Comet 67P is an Achilles tendon. Now, I'm going to show you, see here I'm showing this, how it, all of that, these are eroded features, and then it comes down into a plagioclase ball, which is embedded into the normal bone tissue, and that's what anchors these things in, like your Achilles tendon. Now, look at what I'm going to show you now. This is the one I have here in my own mud fossil collection. All right? As I'm showing it here, I might put it on hold a second. You see that? What I'm showing you there, you may not be able to see that. What I'm showing you is the stalk with those blood investments, and the architecture will be identical. Look at it carefully. You see it? This was the same, this right here, there's a ball. You see this round part? That ball is this ball. And if I had it in my hand to show you, you would see it quite easily. Now, the stalk goes out this way to connect to muscle tissue, and they break on that abrupt transition. Now, these are the fibers coming down, and that was the blood investments. Now watch, and hopefully you'll see the similarity of Comet 67P. Remember now, this is a complete ball, and that ball is spiky as spiky can be, and there's red slurpy stuff all around it, which keeps it from biting into the muscle, biting into the bone and hurting you. But you can see, there's the identical same structure as Comet 67P. So what does that tell you? That tells you that Comet 67P is also biological, and they've also found that it's all completely covered with organics. There's nothing that they expected was there. It's all organic molecules, and they are these same identical molecules that are in meat that is not completely cooked. They're called carcinogens here on Earth. And when astronauts go in, see that? Look at that. How much more clear does it get? And then the strap goes up across the top. You see it here? It goes up across the top and goes up into the muscle groups and holds on tight and anchors this. Now, that's all. This is I'm not sure whether this was a meteorite or whether this was just burnt up somehow. But this is literally what's left of a bone and tendon in placement. All the organics are pretty much gone from this, and that's not the norm with a mud fossil. Normally you have all the muscle, and you have the tendons, you have the cartilage, you have everything. Now, anyway, that is the strap. You see that? Now those boil off or burn off in this case, or sublimate away and leave the little tiny holes, because they're like a strappy little material, so that you're going to have vessels in it. It's just it can't be solid, or it wouldn't be able to squirt around. Now I'm going to show you the Achilles tendon. Hold on a second. All right, I showed you Comet 67P. It's got that big ball on one end, and then these fibers come up, and then there's an abrupt transition right in this area where they break off as they start tapping into the muscles. Now, you saw where it broke off. There's a little blood that invests in here and there if you look carefully. But that, and watch this strappiness. You see that fibrous looking stuff? I'm going to show you what that's like here on Earth from these giant creatures that died and eroded. And I believe I have evidence that there was advanced creatures here long ago. All right, this is the same material that we're talking about in these tendons. This is from giant creatures that died, and this is what left. And they break these things up. You know, there's going to be other pieces that are going to be left here and there, and I'm going to show you a bunch of this stuff. All right, you see that? That's tendinous material. This is the red bloody stuff. This is the limestoney calcified material. And I'm going to show you what it looks like in a human being, only this is a little bigger than a human being. Alright, what I just showed you are some mountainous areas, what are little hills, but this is the material that it's made of. This is the red bloody investment, and these are the layers, and they erode away, and you end up with these things. Up in, I think they have them over in Canada, they have them all over the world, they call them hoodoos and things like that, where they have eroded away and left these little bloody red tops. Now, this is the other strappy material that I showed you before, and there will always be this red, well, not always, but pretty much always is going to be this little red line right on the side of that strappy, flat, rigid looking, you know, it has like the little tiny ridges in them. Now, then this is this other type here. This is the stuff that invests in. Then there's wavy tendons, but primarily tendinous material does not decay. Literally does not go away. Alright, you see those tires? And a truck like that would be able to drive over just about anything. This is that tendinous material that has solidified long ago, and there's that red stripe that is on the side of it, which is the slurpy, they call it, leucine-rich proteins, and that is a tire track. That's all I have to say. I have no clue. They would never, ever become soft again once they dry out. They become hard as glass. And that is what you got here, is a tire track running over a tendon that solidified thousands of years ago. And that's how I'm going to leave it. I got something else to say. Granite is not a natural stone. Granite is the leftovers from processing gold or precious metals. Let me put it that way. You see, this is spectral analysis of granite. There's no precious metals in granite, and granite is completely crushed up and homogeneous, and that is not the nature of natural stone. And it is granular in little chunks, which is also not the nature of basalts or anything like that. And it, you know, which are from volcanoes, and it's not. It's crushed up, processed, and then dumped somewhere. And that's why they see these cart ruts and all these things and footprints and they say they're basalt, footprints in basalt. They're footprints in cretes, in mineral cretes. And they use all these mineral cretes to make the heads and all that other business. They were used in statuary all over the world. And all they had to do was throw in a little iron oxide, the O2, or oxide, the O3. You got red, you got black. It was, and they did this. They were more sophisticated than they are today with chemistry. Much more sophisticated. Alchemy. All right, this is spectral analysis of the platinum group, precious metals group, and these are not present in the other in granite. They're not there, and what it was they had what they call orogenies, and orogeny is where all of this stuff is, all of these precious metals, and they mined them, and they took that stuff and they dumped it in piles called intrusions. Not supposed to be there. Intrusions, granite intrusions, and they piled them there in these homogeneous piles after crushing it and dumping it. And so they have no, and they always show up right next to these orogenies. So they were mining from the orogeny and dumping and creating these intrusions, these granite intrusions. And yes, there was giants in the earth, and every body part from giants is still in the earth, and they're littered in the earth. Stonehenge, the heel stone, is a foot, and there is no question about it. I have a video on. I have 250 videos on YouTube, and they've all been ignored and laughed at and been rejected as being silly because and not a single challenge has been made factually, not a single one. I have all the chemistry, I have all the specimens, and I have all the evidence, and I have all the documentation, and it just needs to be reviewed. Okay, my claim is that geology has missed the boat. And there is basalt, and it is a mafic extrusive rock coming up from volcanoes, extruding out into the earth. It's widespread, but it is not what they're talking about. It's not. It is only from volcanoes. It comprises more than 90% of all volcanic rocks. Well, because it was relatively low silica, and they go on and on and on. Well, it has nothing to do with this secondary type of rock, which I kept talking about. This porphyritic rock is totally different than basalts. And I will show you why I'm saying that. This is how they explain this. Melt migration in basalt columns driven by crystallization-induced pressure gradients. That's insanity. It has nothing to do with that. What it is this. These are the basalt columns. They cut them across. These are veins and artery. There's blood supplies going in through here. This is not. Has nothing to do with any of the things they're talking about. This is identical to the things that I'm showing you as the fascia in mud fossils. It's exactly what it is. There is no difference. And they just refuse to look at this.